Wicka back. Wacka back. Oh, you guys have the almost worst timing ever of catching me off. But here's what we got, and I needed to show this anyway. Lines coming into banana connectors, and they always have this fancy screw that you see here already preset, and I know it's going to be offset a little bit, the shot, but I do what I do. Basically taking my tip here, soldering tip, just putting it right to the side of the case, and then I'm going to feed in. I already have a slug of flux inside the hole there. Now the hole is on top because I don't want the solder to fill up the hole if I can help it. Now some is obviously going to get in the hole, but as long as it's not just all over the hole, if you know what I mean, will really help in filling just the hole up, pushing it in to hold the wire. And then once the wire is held, while that's still going on, whoop, this takes it a little bit to cool down here. So it's still screaming hot. And I got it on. Now can I get the screw in? It's always a little bit, I always do the race. Screw is, oh, it's a 0, ain't it? No, it's starting. Wow. It's starting, and yes, it's hot. And it looks like it's set up good. And it's tight. And what do we got? So this one's done just before I caught you guys. Or you caught me, oh my gosh. Nice, tight, solid. By putting the screw in after, you're basically like double clamping on it because it's already soldered in pretty much. And then you put the screw in on top of that. Folding it over and then screwing into it. Honestly, noisy girl, noisy dog. The best bet, I think, would be to use furls like this. Just put a furl on the end, then stick it in, and then put the screw to it. But these, some of the, I guess the cheaper ones, which I just grabbed some that I had. I got a whole bunch sitting here. Some come with the set, but I kept them off to the side because I like the alligator clips that came with it as a setup. So, yeah. And you know what else I like to do is put some silicone glue down inside here. And that actually helps as strain relief, but they should be fine. Now you're like, you got my backward derpy. What are you going to do? How are you going to test and do anything, you know, because they're backwards, you know, like. And I'll be like, oh, I like them. Kind of got a lot of things set up like this, because this way I can use the pins. Or up here I got my connector for the claws. Oh, I got 2 claws. I got the long claws, which I probably won't need these, obviously, with such a big setup. Polarity doesn't matter with this tester, by the way. As you can see, these can clamp on the ends. And I even have a little smaller set of them, or just the basic generic set, which I actually have them set up with. They're actually, my main set is the bananas with them. Set up as these guys right here. They actually come in a set. These guys, the black and the red. As you see. And these don't actually have the spin to them. Let me tighten that just a little tad more. If it'll go, it might not. Oh yeah, it's tight. So now it's making sure. I think I'm going to do a little bit different color than the blue. But I got my blue is here, and I can start off with some red, some green, some whatever. It doesn't much matter. The biggest thing for me is getting the distance right. So, I don't need this one or these. I can rehang them later. Just get that out of the way for now. And get back at it. So, this unplugged. Let me get this cleaned up. I kind of use this as a special one, so I try to always make sure I put a nice coat of good solder, fresh solder on it before I shut it down and let it cool down. So unplug. So it takes it a bit to cool down. So now I'm just wiping it through my coil. My, what do they call that? Copper, brass, scrubby scrub. Yeah, scrubby. It's a scrubby. That's really what it is. It's a dishwasher scrubby. There, got a big load on the end. Let that cool down or knock it off, one or the other. Sorry about that. I hate when that one sits with just crap on it. Okay, on to where are we at here with this. I need to look and find where that capacitor. One thing I noticed on this, and it's not marked on here, if you look, is there's just a plus symbol where the capacitor goes, which is right here. This capacitor, right here. Just a plus in the middle. Well, is it plus where? Left or right side? So there's no yes or no answer on that, and I'm looking to see where it lays out. If not, I'm probably going to have to try to start the circuit up and then test it and see if it's positive or negative and then apply it. I'd like to actually find it in the circuit here as I got that printed off. Let me see what size we got here. This is 50 volt, 22 microfarads. Let's see if we can find it. .50 volt, 20 microfarads. It comes off. Test leads, do they run right down through? I thought they did, so let's see where they come in. That's the battery. Test lead. .50 volt, 22 microfarad. Where are you? Oh my god, come on. That's 33 nanners. That's 22 microfarads there. Is it 50 volt? Because there were some other. That's 27 picofarad, 27 picofarad. No, 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 no. I also put in the VRs, which are, they're just trim pots right here. There's, what the heck were they? One was, what was it, 20K? Let's see what they say. 102, so that's 1,000, 1K. And 103, which will be 10K. 1 0 and then 3 zeros will be 10K. That's got to be it. So we'll say that's it. And here's our line, our positive. Pin 1, lead 1. So it don't matter. Lead 1, pin 1. So you're telling me positive and negative doesn't matter? That doesn't make sense. Still, you know, maybe it doesn't. Maybe that's why it's in the middle, because I've also seen circuits where what they'll do, you got, oh, maybe they did. You got a square and a round hole, and the square will technically be your ground, what I've seen. They're both square. So, you know, I'm going with it as, right now, I'm going to put it on a technical branch. Breach. A technical timeout, we'll call it, for that. And we'll come back to it. We'll test it with the circuit lit. Got my voltage here set up, and let me make sure I got a 9 volt that's ready to go and charged. Yes, you can charge 9 volts. Don't let anyone tell you different, because they are lying if they say you can't. Slowly though, and it's alkalines, not all of them. I found mostly alkalines, cell batteries like this, and in a couple weeks it'll drop a little bit, but I'm just pretty much topping it off and letting it ride. So I want it like, it's not like a big, you're not gaining a whole ton out of it, believe me, but it's enough for me to run my little tester and make it work. What did I? Can't get that to stay on. Oh, that's compelling stuff. Shit! Ah, sorry about that. God. Yeah. Speaking of God, today is Easter, and that is a quite horrific day going back into history, but we do celebrate because it was, again, in commemoration of our Lord and our Savior. So happy Easter to everyone, all of you out there in YouTube land. This just needs a little tweak. Boy, it does not want to cooperate at all. Okay, can I sneak that up? Beautiful. And get me up to 9 volts. Seven, 8, 9. And sounds good. Beautiful. Alright, that's just trickling in some voltage. And make sure everything else here aligns. So yeah, I think that can be a flip-flopper, especially like they say, it's not a polarity sensitive, that's why these are both red. So that doesn't matter, and it's a one-off. Here's the inputs in. I'll put them up in, this will make them red. What should I make them? I'll just do a hoop. Shoop. I can do this for capacitor. Yeah, them are the hoops on the end. And here's my, down here is the battery. Battery plus is here, minus there. Alright, pretty much wrapping her up. I really wanted to show you guys though the soldering the banana connectors. I've tried a whole bunch of different things, and that's what I found works the best. And for the strain relief and that you get out of it, it holds the test of what it's worth. So it's definitely what I found to be the best. Doesn't mean you have to like it or even look at it or think about it, but it's just, if you it's just my opinion, which are like wah wah. Okay, the plus and the negative, I'm not sure with, because I put these in and covered it up, and I'm not too awful worried about it. I'm gonna put it in one way. If it blows, then I'll just flip it. How about that? Then I'll know. But these, I do need to know which way these are going in first. Positive or negative, which showing. That won't fit in there. Will this one? Yes, this one will. And the negative is always the big, it looks like a big anvil if you look real close. Oh wow, that one got, like, looks like it got jerked out of something. Just bent right over. Right at the very tip, each one was. Still is. Let me snip that. How tall do I want these? Oh yeah, I'm taking a good chunk off. careful not to get these wire leads all over the place, because they'll end up sticking in your foot or someplace you really don't want them. And I've been there, it's not fun. Just gonna put a little black so I know I don't have to keep looking at it. You know, I'll put a little dab on it. Maybe just the side. I was gonna say the top, but if it's shining through the top, I don't want it to. Let's see if I could guess. If I could see enough. Not even just enough to guess. Almost, actually. I wonder if I can. If I can peek in there with my snoopers here. Oh gosh, there's nothing. I mean, there's nothing to even see. Dang. Dang. I'll go like that. Okay. I have not tried to clean up the board or anything yet. That'll be after, when I'm done. So I think we're about ready to fire this thing up. Start running it through its paces. Let me double check that we're done with this page. Resistor. Operations. Oh, I messed up earlier. I was saying it runs, I like this meter, it runs at a higher voltage. It's actually just the opposite. It runs at less than 100 millivolts. And that way you know it's not going to turn anything else on in the circuit, which is good, which is very good. Okay, component installation sequence. Okay, this is just telling the kit package, plastic bags, construction we talked about. Some kit builders are nervous about soldering. That's just going to talk about if you want to use these sockets to build up off of the board. I always like to use sockets. That's why I have a whole stack of them that I've desoldered to save, because they are very nice to have. Them things, that's why you socket it, because that seems where there's a problem, it's going to be right there, and instead of having to re-solder it and possibly pull a trace, do something crazy like that, nope, just pull an IC out with an IC puller or a fancy set of like tools, I guess you could call them, and move on. Oh, I could almost see the LEDs, which way they're put in. Just about. Wow, it's so close. Can't tell though. Okay. Strip approximately. Oh, they're wanting to talk about what we already did. If you did not install the headers into 7-segment, we did. Before handling a 7-segment spig, make sure that you are grounded, as they are sensitive to static electricity. That's okay. I got backups. Orient the 7-segment. They're calling it a 7-segment display. There's 8, there's 3, and 7, and the period makes it 8. Come on. Why, people? Once all the components are installed on the PCB board, hold the component side up, right, light. Oh, use a light to check through it. I talked about that earlier. Battery connector, when all the components are on the board. Solder the battery snap connector to the battery pads on the PC board. Negative and red, the black. It's just different color come out. This is the last page, so we know we're into something good. What do we got here for these? Are they going to be marked, labeled? Hard reading the color. Green, so that's going to be a 5. That's either going to be whoa, 1, 2, 3, 4. 1, 2. 1, 2, 3, 4, 5. 1, 2, 3. Oh, okay, 4, 5. Okay, brown. brown with a gray, so there 19 with a 0, 190, and a blue, which is 6. 190 with the 6? What? Something mega ohm? That don't sound right. And this one, let me write meg. Hi meg. They tell us what they are, but I just want to make sure that okay, gray is probably going to be on the end. So brown, gold. Wow, it's gold. 8? Remember, 8. Gold, 8. Gold is, gold! Oh, come on, gold's at the end. It's the tolerance. Gold is tolerance, so just reading it. Gray, which is 9. Brown, which is 1. 910. Then gold, and that's going to go back to 910, and gold is greater than, so it goes back 1, 2, just goes 1, because gray would be 1, 2. Believe that's how it's, so that's what, 91 ohms? That doesn't seem right. It seems like you could write it up easier than that, but we'll see what they say in here. So this one's 91, and that one's high megs. We'll see what they tell us what they okay, set both VR1 and VR2 to their mid-range positions in the and connect the 9-volt battery. Let's see. That's 1. 2 is 9 volt. You should see something on the 7 displays hopefully on the left hand one. Right there. Press the push button again and the meter should turn off. So that's 3. Turn it back on and short the leads together. Let's write 4. Short. The meter should read something less than 0.5 ohms. Eyes are doing that dumb thing again. Sorry. With the leads shorted, press the push button again and again to 0. What? With the leads shorted, press the push button again to 0 the test leads. Okay. With the test leads shorted, press. Okay. Short and press. And to set 0 benchmark. Okay, the reading should be with the left decimal lit. That's number 5. So it should read 0.00. The reading may bounce around plus or minus 0.02 ohms, or so due to various in lead contact resistance. Okay, calibration. Calibration time. Come on, yeah. Calibration. It is best to calibrate the unit before assembling in the box. That way you can correct the assembly and clean up the board is always nice, and any errors that occurred in calibration without having to disassemble the board from the box. With the meter on and the lead zeroed. So 6. With it on and zeroed. With it on and 0. With the meter on and lead 0 as described. Connect supplied 82. Okay, 82 ohm. 7. Hook up. (82 ohm at 1%). Calibration resistor to the probes and carefully adjust VR2. So adjust VR2. One, two. Till the meter reads 82. Then check that it reads the supplied 5.6 ohms. Then check that it reads the supplied 5.6 ohm calibration resistor reasonably accurately 5.2 to 6.0 with the middle decimal lit. Alright, so that's a 5.6 and then 10. We hook up. .6 ohm. And that should be 10, so 11. Battery. Warning setup. Skip this bit if you disable the automatic switch off function by leaving one lead of R25 disconnected. See the optional modification section at the end of this document. This adjustment is easiest if you have access to a variable DC power supply. If not, you will need to build the little circuit shown here. And it's just a little circuit with the, was it a 2N3904 transistor. And it looks like the meter. But we got a DC supply right here. So one of these they're saying is 82 ohms. How did I get 91? Gray. I said gray was 9. White's 9. Gray is 8. So where's gray? Great looking gray. No, I can't see it. Where's that gray? Sure looks. Come on. Brown. Oh, gray. Yeah, gray brown. So this is. We got 82 ohms. And what was the last? 5.6. So this is definitely 82. Don't need that. Can I write on it 82? Probably not. Have it seem legible. So we'll do the next best thing. That guy's 82. The other guy be 56. Let me double check. Yep, green, blue. So DC supply, but first we gotta hook up our 9-volt supply. So bring it on in here. That is sitting right here. Get some of this stuff out of the way. A ways. Okay.